Hi, in this lesson we're going to talk about reflectance curves or the Fresnel effect. So for that, we're just going to pay attention to this middle sphere, the one that has a blend material. So first thing I'm going to do, this is the same file that we were working on. I just saved it as O5 begin. I'm going to hide these two other spheres, display, hide selection. And now we're just going to pay attention to our blend material. So the Fresnel effect, or when it comes to reflection, is based on a series of equations by this French physicist Fresnel, I think from like 150 years ago, or something like that. And it describes how most materials, when you're depending on the angle from the viewing point, will have a different amount of reflection. So what that means is that things that are looking straight at you will have a lower reflection value than things that are completely perpendicular to the viewing point. So the moment you just turn that on and we render again, let me make my region bigger, you're going to notice how our reflection completely changed. Here we have very little reflection, but on the edges we have a perfectly 100% reflection. And the Fresnel equations, what they tell us is how this curve is working. We can change that in V-Ray by changing the index of refraction. One of the things that the V-Ray shader lets us do is that we can come here, unlock our refraction index of refraction from the refraction element to the reflection element. So now what I change here is going to be completely independent than what I use in my refraction. So let's come back here. If I change this to a lower value, we're going to have way less reflectivity here. You can see that, but we still get this 100% reflectivity on the edges. If I make this a very large number, like 5, this is going to start getting closer to no Fresnel effect at all. So it's a really useful way. Most materials use some kind of Fresnel effect. I would say almost all of them. The thing with the Fresnel option in V-Ray is that we have no control over that shape of that curve. And one of the things that we're going to learn here is how to, instead of using the Fresnel option in V-Ray, I'm going to go ahead and turn this off, create our own curves. So this is what we're going to do. Let me bring back my Hypershade. Here it is. Blend material. I'm going to show this graph. Move this down here. Let me make this bigger. And the first thing that we're going to add, it's a sampler info. Sample info. Probably you guys are familiar with this node. This is a very useful node. We're going to be using it a lot. One of the parameters or the outputs from the sampler info is what's called phasing ratio, and it's just going to give us a black and white information of whether or not that face is facing the camera or not. But the problem is that this is going to give us what's facing the camera is going to be white, and what's not facing the camera is going to be black, or what's completely perpendicular to the viewing angle is going to be black. And in our reflection, we want the opposite. We want what's facing the camera to be black and what's perpendicular to the camera to be white. So we're going to use a reverse node. Here we go. We're going to connect phasing ratio to any of the inputs. I'm going to use X just because it's the first one. And then to be able to draw our curves, we're going to use a remap node, remap value. And this is like pretty much what this node does is that it's going to take whatever input is white, it's going to like remap it. So this is very useful if you want to do some kind of like gamma correction or something like that, where you need to remap the values. So I'm going to close this in the meanwhile, and I'm going to connect my output X because we're only using input X, and I'm going to connect it to my input value. Now, if I open my graph, what's going on? Everything that's black, it's here. Everything that's white is here. And right now we're having a linear remapping or a linear progression. But we want to change that so we can control this Fresnel curve or reflection curve. We're pretty much just going to be guessing our reflectance curve without having to use the Fresnel effect. And the output value, I'm going to connect it to out value. my reflection color amount. So if we look at our swatch here, we can see we're having some kind of Fresnel effect, but it's linear, so we're not having that curve that should happen in real life physics. So here we have like absolute no reflection, and then it goes in a linear progression to have it 100% reflection. So that's an easy fix. We just come to a remap value and we can draw what we think a Fresnel curve would look like. It's something like this. Let me switch this to spline so we get like a smoother curve. And then I'm just gonna adjust these guys. So if you were to actually map, yeah, something like that. If you were to actually map one of Fresnel equations, the result for most index of refractions would be something like this. Some of the things that's going to change is what the value at 0 degrees is. Right now we have it at 0. We can raise it up a little bit, and how fast this goes up. But this is pretty much what the curve is going to look like. We can always come and adjust it a little bit so it's smoother. Now if I close this and I re-render, we have a more, what it would look like an actual Fresnel reflection. Okay, so if we really want to recreate what an actual real-life material would look like, one of the things we can do is that we can come to this website, refractiveindex.info, look for the material we're looking, let's say organic material, and look for some kind of plastic. I don't know if this other. Okay, commercial plastic. We'll just pick one of them. It's going to give us all kind of information, but we're really interested in the reflection calculator. So here we have what that graph should look like. One of the things I'm going to do, because in 3D we don't really use polarized light, is that I'm going to turn off both polarizations, and this is the graph that we want. So the first value that we're interested is this one. This is going to be our value at 0. So we can come, like, let's say 0.039. So we want this guy to be 0.039. And then we can just try to see it starts going up at about 50 degrees. You need to understand this is not going to be degrees. This is in percentage. So you would have to do like a quick math. So, but then we just want to copy this graph. I mean, there's Python scripts that will do this for you and all kind of stuff, but I'm just going to do it by hand. I like doing these kind of things by hand. Now, that looks a little bit better. Maybe raise this guy a tiny bit, raise this guy a tiny bit. And let's re-render. So that actually looks like plastic. That would be, if we are able to completely copy this graph, we would have the correct physical reflection curve needed for plastic. One of the reasons I like to create my own graphic or create my own graph or curve instead of using the Fresnel effect is that one of the things you'll hear in a lot of forums and on a lot of websites is that metals do not use a Fresnel effect, but metals have a very particular reflectance curve. And when we use this remap node, we can create that specific reflectance curve. So these kind of curves, this one that looks like this, are very common for dielectric materials or materials that have no kind of conductivity in terms of reflection. But when we're going to use metals, which are called conductive materials, let's see if I can get, let me find a metal here, something like, okay, silver is a good example. Let's turn off both polarizations. As you see this curve, it looks like a straight line, and before it goes up, it actually goes down a little bit. That's very common in metal materials, and that's something that the Fresnel effect will not give you, but if you turn it off, you won't get it either. So if I take this node, I'm gonna bring this guy up. I know it's like somewhere around here, somewhere around here. I'm just gonna delete some of the points. So the curve for most conductive materials is something like that. I'm exaggerating a little bit, but I just want you guys to see what the curve is. So it goes up a tiny bit, then goes down, and then goes up again. Of course, this is not exact, but it's just to give you guys a little idea. Okay, there we go. And then if we render this, the difference in terms of the naked eye is going to be very, very subtle, but it's going to give us that tiny bit of realism that a lot of times normal shaders don't have. And it's that somewhere along these lines, it's going to be a little bit less reflective than here. So you're going to have like reflection, more reflection, a little bit less reflection, and then 100% reflection. So this is one of the advantages of creating our own reflectance curves. You can either create like a normal Fresnel curve for a dielectric material, or you can create like a more conductive for a metal material, but you have complete control of creating that reflectance curve, and that's kind of what we want to achieve, because we're going to be creating a lot of custom-made materials, and we want to have complete control over these guys. So I'm going to stop here, and on the next video, we're going to start taking a look at layering different specular layers, different reflective layers, so we can create just different specular highlights or different reflection curves within one material. So we'll continue on the next video.